We get asked all the time by repairs, which measuring system should I buy? Now, in theory, three-dimensional measuring systems are all the same. We're measuring length, width, and height at specific points. What makes them different is where we get those points. Now, there are four main things you want to consider: the database, the accuracy of the measuring system, the technician training and use, and last, the effects of the system in the repair process. And when people think Celette, they think fixturing and not necessarily measuring. But the fact is, Celette's been measuring since 1953, longer than anybody in the industry. Today, Bob Stevenson from Celette is here to discuss how measuring systems are built and used by technicians and what makes their database different. Welcome to the show, Bob.
Thanks, Jason. Thanks for having me.
So the first question I've got for you is, what makes the Celette database different?
Well, the Celette database from day one, from back to 1953, was always built off the CAD drawings. We never used a car to create data. The reason being is the car could be wrong compared to the CAD drawing. So CAD drawings are zero tolerance. And that's where the OEM intends for the car to be built when it comes off the line.
But there's some build variances in there potentially.
Of course, at the car manufacturer line, there is some tolerance allowed for each part of the car. So each part of the car has a different tolerance that's allowed at end of the line, whether it be length, height, or width. Every point, say a strut tower might have 0.5 on the height and 1 millimeter on the length.
Okay.
When we build the CAD, off the CAD drawings, we always use zero. We never use a tolerance. So we're starting with basically a brand new perfect car to create the data.
You're starting with a more accurate piece of data to start with than the actual vehicle itself because of that build tolerance.
Correct. So some measuring, or most measuring companies will use a vehicle to create their data off of.
Okay.
They'll take a car off a car lot, put it on a lift, hook up a measuring system to it, and create their database. The downside to that is, number one, you're starting with a vehicle that did have some tolerance coming off the line at the factory. Then the car was on a transporter, train, or truck, could create a little bit of variance.
Sure.
Then the car comes into the shop and or the workshop for the measuring company. They measure the vehicle. There could be some technician error measuring the vehicle. And then on top of all of that, we have some tolerance that's with the actual measuring system.
Okay. So we've got a vehicle that may not match the CAD data to start with, which is the benefit of having the CAD data to begin to build your measurements.
Correct.
Then we've got some potential technician error, some human error built into it from the technician actually measuring a vehicle that may be slightly out of tolerance to start with, and then measuring equipment on. So we got a couple of millimeters potentially from the factory, we got another couple of millimeters potentially from the technician, from the human error, and then maybe that machine itself, the measuring equipment itself, might have a couple more millimeters as well?
Yes, that's correct.
Okay, so we're starting with versus 0 millimeters difference from the CAD drawing. Before we even get out of the gate, we could be starting with 5, 6, 7, or maybe even more millimeters of tolerance from the just to build the database.
Exactly.
Okay. Now, when you're talking about CAD data, CAD drawings, what exactly is CAD, and how does it help build your database?
CAD drawing is computer-aided design, software used by the OEM to create basically the blueprint of the vehicle.
Okay. Now, from a technician standpoint, what are some of the benefits of having that CAD data in the measuring system?
So when we start with CAD data, we know that we're starting with zero tolerance. So whether we're using a measuring system or one of our jig systems, we know we have good measurements. How many times has it been where you get a panel, maybe a door, and it doesn't fit the vehicle correctly, and automatically we blame the part, right? But maybe it's not the part. Maybe it's the data that we're using to fix the vehicle.
Okay, so even if the data itself is telling us that, hey, the structure looks okay, it may be off because of, again, the build tolerance, the technician measuring the vehicle to build the database, and the measuring system itself, versus if I got the CAD data, if the measurement's off, I know it's the measurement, not the measuring system.
That's correct. So now we take all that error and we put a rail in with it using bad data. What's that do to the vehicle or the person driving it?
Great. All right, thanks, Bob. That's some great information. Really appreciate that insight. You know, today's vehicles with all the advanced driver assistance systems, it's more important than ever that we've got a good structure on the vehicle, that we've got our proper steering, suspension, angles and alignments. And without that, without good data for measuring our vehicle, it's not possible to repair the vehicle properly. So if I'm starting with a vehicle that's already potentially, 8 to 10 millimeters out of tolerance, with all the measurements in my database, chances are I'm not going to be able to be as effective as I'd like to, and maybe my customer's not as safe as they should be. Starting with the CAD drawings and that zero tolerance information is a great way for the technician to feel comfortable that the data that they're using matches what the data that the vehicle maker had in the first place. Join us for the next video in our series on measuring, where we'll dive deeper into measuring tolerance of the machine or the equipment itself.